Okay, good. Yeah, hello again. So we have a panel session now, and I think we will do it in a very relaxed way and just see where we go with our discussion points. We have a topic. It's recent advances and challenges in robotics and AI. So very, up to date and very much in line with what we have heard here at TAROS. And so we are looking into that, different angles. We have a number of experts, of course, on the panel. And maybe we can go around. Maybe I'll start myself. So I'm Kaspar Althoefer, and I'm from Queen Mary University of London. I'm a professor of robotics engineering. And here's a colleague, Rob. And
Yes, so I'm a veteran engineer, not an academic, although I've got some kind of academic roles that I've been given over the last few years. I've worked in different industries. I worked in the aerospace industry, looking at, but using robots to demonstrate algorithms. I then moved into the microelectronic industry, so I made system-on-chip devices, which are of course used hugely in robotics. And then at Dyson, I've been the product technical lead for the last two robots that we've taken to launch. So that's just a little bit about my background.
Good, thanks.
Hello, I'm Cavalcanti. I'm a professor at the University of York, and I'm the director of RoboStar, a center of excellence on software engineering for robotics. So I bring here the perspective of the need of trustworthiness for our robots as something key for us to be able to really take the robots out of their cages and realize all the potential that the presentations that we've seen in the last 2 days has indicated to us, bringing these robots to be collaborating with humans, working for humans in a way that people will appreciate it.
Thank you. Hi, I'm Radhika.
Your microphone is not on, I think.
Basic thing. Hi, I'm Radhika. I've been in the world of robotics for more than 15 years, working in small, medium, and large enterprises. Have been always in the R&D space, applying for grant funding, and now I'm with ARIA, sitting on the other side as a funding body, so a different experience. So started at ARIA 2 weeks ago as a technical specialist in robotics and trying to see how we can shape up the UK robotics space for longer term challenges. So, yeah.
Thank you. I'm Jonathan Walker. I'm the innovation lead for robotics and sensors at Innovate UK. Robotics wasn't my first career. I started in the oil industry, oil and gas, as an engineer for 10 years. But then in 2016, did a master's in robotics, and I've been a robot service engineer, automation engineer, and sales person in robotics before going to Innovate UK to be a funder.
Good, thank you very much. My thinking is that we start with some points that I have written down. I hope you like them, and have a bit of a discussion here, but then we are of course also very open to open it up to the audience. So if you have any discussion points, if you want to contribute to what we are saying, by all means, let us know. I would like to start with what we heard yesterday. Professor Nandi gave a fantastic talk, keynote presentation yesterday evening, and at the very end, in particular, he was talking about, what could robots be used for, what should they be used for, and he was mentioning about robots for good. And but at the same time he was saying we should not slow down, so we should be, as scientists and researchers, we should be, keen, to continue with our research and really, go in there, because that's where our passion is, and we want to, create new things. But at the same time, he was also, talking about the responsibility that we have, that the public has, that the lawmakers have. And so that's what I wanted to kind of take as a starting point. So in a way, to ask, where we're going, I mean, robotics is improving all the time. Is there a danger that robotics might be used in the wrong way? Is it okay to pose it as a question, and any volunteer to start speaking about that first? Okay.
I'd be happy to start.
Okay,
Yeah.
good.
I'll give a view that is a bit technical,
Okay.
but I will start by saying there is definitely a danger. What we need is for the whole of the society to be engaged, not only the roboticists, not only the hardware engineers, the software engineers, but it's a multidisciplinary issue. We need the lawyers, the philosophers, the psychologists involved in the conversation. We're not going to stop the advancement of technology. I will give you some Wikipedia knowledge, just like Professor Nandi, where I found out that the first time in which people worried about advancement of technology in the UK was in the reign of Elizabeth I, when tailors were worried about the sewing machines. Oh. So it's not going to stop. So my technical answer is that we need to enable this conversation, this very multidisciplinary conversation. And so we are looking at technologies that allow you to do what I call operationalize the requirements. There are social, legal, ethical, cultural, empathetic concerns that you need to have when you are designing your autonomous system, your autonomous robot. And the process of understanding what are these concerns may even end up by saying, oh, we're not ready to develop that. But we can, from a technological point of view of software engineering, understand and capture those requirements mathematically and give people the power to say, I can show evidence that my autonomous system satisfies those requirements. Whether those are the right requirements, then we need that language that allow all those colleagues from the wider society to contribute. So yes, it can be dangerous. Yes, there are things that us as technologists can do to help.
Okay, thank you very much. Maybe Jonathan, you wanted to add?
Thank you, Kaspar. I'm very much concerned with getting robots into the commercial sphere so they can have a positive impact on the economy and on our lives in general. But of course there are concerns from a lot of people that robots take people's jobs. It can be true in some situations, but generally there are not enough people that want to work in manufacturing. In the health system there are 84,000 open vacancies. The average age of construction workers in the UK is 55 years old. So if for us to build 370,000 houses a year, which I think is the target at the moment, it's going to be impossible with the current workforce, and young people don't want to work in that sector. So if we use robotics to take away some of those dull, dangerous, dirty jobs, it's going to have the effect of bringing young people into those industries as well, which is going to be good for them, good for the country, and good for everybody.
Okay, yeah, good. Thanks for that. Yeah, Rob, okay.
Yes, yeah. Thanks, yeah. Yes, so I'm not sure what's going to bring robots, to be ubiquitous in our daily lives. Is it going to be a kind of a push technology, which I see a little bit like the mobile phone, where the advancement in technology is giving us new capabilities that we didn't have before? Or is it going to be more a kind of a pull technology? As you mentioned, we need, for healthcare, for example, there's a big gap in the number of people we need to do it. So is it going to be more of a, going that way, that there's a need that the robots are going to fill? So I'm not sure if it's going to be a push or a pull type technology. My feeling is it's going to be more of a pull. That we're going to find something that we need to fill a gap, and then we're going to use robots to do it. And healthcare seems like one possible area.
Maybe, yeah, Radhika.
I
Yeah.
mean, picking up on what Rob and Jonathan were saying is safety comes, like the issue of safety can be tied up with any new technology. So if you're taking, for example, mobile phones, there are lots of bad effects or side effects that we are seeing in younger generations using mobile phones.
Yep.
So, like, should we stop making mobile phones, or is that not a useful technology? Answer is no. Using it in the right way. Going back to mature technologies like, for example, cars or automobiles, when they first started, probably the roads were not made for them. There would have been more accidents in the past. So it's making sure that robots are put in places where they can bring in lots of benefits is the way to look at it. And there is a danger and safety element involved in any new technology, according to me.
Good. I mean, if the audience if anyone wants to raise their hand, if there is something anyone wants to contribute, by all means. Yep. Okay.
Thank you very much. I would like to ask you, those are very good points, but in terms of external collaboration with the universities from abroad, do you think there's awareness, or if there is any regulation with regard to the export control when it comes to collaborating there's a single-use product services, but there is those who can be used in a wrong way without our research community awareness. So are there any regulation in place currently that are followed in the UK, but also are the robotics community aware of these issues as well? Thank you.
Yeah, I can maybe start. There are definitely export controls in place. So anything that is being developed in the UK needs to go through a very thorough filter before it can be passed on to anyone outside the UK. And that is more strict with certain countries, but also even applies to EU countries. So you asked whether the robotics community is aware of that. I have to say myself, I was not aware of the details, but I'm now aware of it. I don't know what your view is on this, but definitely, and it relates to any kind of things that we develop in our labs. It needs to be checked whether it is okay to pass it on according to the export control list, and if it's not okay, one has to effectively apply for a license to be able to have this kind of exchange of ideas or hardware with other parties. Yeah.
Sorry, just want to ask a clarification. Julia, is your question about is the robot that we built safe enough for someone to use, or is it about retaining our designs and IP within UK if it is developed in UK?
It's a good question, because we start with a dangerous robots, dangerous use. Dangerous should be defined if it's safe, related or wrong purpose, with the wrong intentions. Because those could be the best intentions from the research community to follow that to
Okay. So I was mainly referring to intellectual property, but maybe you want to add about the safety aspect?
Yeah, regarding the safety aspect, I think it should be something to do with the policies, and also there are elements of getting products CE marked. So in some markets, so for example, if you're considering a pharmaceutical or lab market, getting a robot to be certified to be used in those settings could be much more challenging and lots of loops to jump through. When it comes to other places like in automotive, where it is much more mature to use those, and collaborative robots again as well. So yeah, I'll let others add.
And for the kind of consumer robots, there's lots of compliance things that we have to adhere to before we can sell the robot, which is to do with the materials that we use to make the robot. It's autonomous behavior. So if it has a fault that you're not able to restart it multiple times, and then get kind of a creep in heating and things. There's compliance we have to do about the power that the robot takes, and also when it's charging. So there's all these kind of compliance things that you have to comply with to sell it around the world. RF as well, radio frequency, EMC, what you're emitting, and your susceptibility to EMC, ESD as well. So there's all these compliance things that you have to adhere to sell it. Yeah.
Can I just add on to what Kaspar was saying about the potential dual use? Almost every technology can have a potential dangerous use. There's something called, I think it's called the National Security Innovation Act, where the government will check certain technologies and make sure that they're not being sold off to countries that are judged to be enemies currently. Innovate UK is actually working on a program at the moment where we're trying to ensure that people that come up with innovation ideas can protect those ideas so that they're not used for dual use.
I was hoping that you were going to mention that because I wonder if her question is exactly related to that. Regulations, I think basically universities have their ethical committees and we all need to make sure that we interact with them in the appropriate and required way. And I think the funding bodies are now basically checking and making sure that that happens. And I think it's a positive thing. I think we all as researchers need to be aware of the dual use issue. Yeah, it's always possible. What are we doing? We have that responsibility.
Yep. So thanks for that. So you talked about transparency already. So maybe we can incorporate also the AI bit a bit more and speak maybe about trustworthiness, and also maybe link to that. Should we involve more the public about what we are doing? Be more transparent. How can we do it? How can we make sure that what we are developing is then also accepted by the public? What are your views about AI, the black box problem, and trustworthiness?
That is a big, big challenge. So what is trustworthiness? So the UK program that I mentioned in my talk, it's been a very interesting opportunity in the last 3.5 years to work in the area to identify several aspects of trustworthiness, and there is safety, there is security, there is verifiability. So RoboStar has been involved in 2 of them. Verifiability is the ability of a system to be verified, to provide that evidence that I've been talking about. Resilience is another aspect of trustworthiness. So it is a multidisciplinary problem, as I explained. There are all sorts of aspects. So when you think about, do I trust that person? Do I trust that institution? Do I trust that machine? I think you can already identify that there are so many aspects that are involved in this. It starts with expectations, and they are not independent issues. So, for instance, an insecure system can pose safety concerns and so on. So there are lots of issues, and of course AI brings one big bad wolf in this story, which is it's a black box. But it doesn't need to be. There are developments already that are allowing us to learn models of these black boxes that allow you, under certain assumptions, to start to make deductions of what you can expect. There are techniques that allow you to measure the uncertainty level of such a black box and then decide, oh, it's not working according to the metrics of certainty that we expect. We can then change and adapt and so on. So it's a very exciting time. It's a very exciting area. It's difficult.
I think it's also made more difficult because you can imagine one AI system on its own that you need to try and make sure that it's safe and secure, etc. But then if you're coupling it up with other AI systems that are interacting, then that makes the problem much more difficult. When you have this system of AI components interacting, that would be another interesting challenge, I think.
Maybe just to add, are we going too fast, or should we slow down with our inventions and also with the implementation of those? I'm thinking about self-drive cars.
I mean, I don't think we can stop if anything is going fast. It's only about watching the space and then see where it gets to. Coming back to your question about AI, safety, bringing it back to how it applies to robotics, I'm a strong believer in involving the end user, be it common man using it or be it an end user in a different market, maybe a farmer or maybe a lab chemist, involving them right from the beginning of the development of the technology is more like they feel assured about using that technology. So for example, when it comes to designing a robot, if we are organizing something where public and community can relate to it, that's when there is acceptance and less of inhibition about, oh, are the robots going to take away our jobs? So in the same context, putting in a kind of a teaser about what's coming from ARIA is we are planning a big grand challenge in terms of robotics competition, but we like to design it in such a way that the grand challenge looks more like at the edge of possible at the moment, which you can't imagine, it can't be solved straight away. It might need a lot of development. But at the same time, set up some sub-challenges as part of that grand challenge where people can still relate to. Even a high school goer can relate to some of the challenges, or a lab chemist or a food processing company can relate to how things are done. So those are the kind of things that we are looking at to engage the community and remove the inhibition of robot acceptance right from the beginning.
Okay, good. Yeah, you want to add? Yeah, okay.
Yeah, I completely agree with the black box argument about AI safety, but there's also the ethical challenges that the LLMs are just harvesting data without people's consent.
Large language models, yeah.
Large language models. On the black box side of things, there's a couple of companies trying to put a layer on top of a neural network to make it explainable. And de-risk was one of them. And you really need that when you're going to use it for applications like aerospace. If it's flying a plane, you need to know 100% for sure that it's going to work. You can't just rely on a million tests, because maybe on the 1,000,001th test, the plane's going to crash.
Yeah, I mean, it's good that we have the two of you here. Maybe a comment on how funding bodies could maybe direct the research area and the development, or the directions which are to be taken.
This is a bit of a controversial opinion. It's my opinion, not an Innovate UK opinion, but I think that we should be funding hardware rather than AI development. With a lot of the money that goes into AI goes to companies that develop something in a couple of months, and then they can just copy it infinitely and sell it as many times as they like. Whereas with hardware development, you know yourselves working with hardware, it's very difficult. It takes years and years, and there's a big gap between where public funding finishes and you still need to do a lot of R&D to commercialize that and be able to get private finance. So I think that's where we should be focusing our public funding.
Yeah, but this is in line with area, effectively.
Yeah, exactly. Yeah. That's what I was going to say. So ARIA is doing the right thing then. But going back to your question on what should the funding bodies be doing, although I'm quite new to ARIA, and ARIA is working in a slightly complementary way to other funding avenues that we can tap into within UK, it is led by these dynamic leaders called program directors, who come up with their own vision of where they see technology could impact the society in the longer term. And they are the ones that were successful in a big pool of applicants, and their vision was something that won the won the eye of ARIA's funding. So it is a bit of in their creative idea. So it's a risky way of doing it, but probably that is the way you can generate the breakthroughs. If you're relating it to similar challenges like DARPA in US, so that's the model that ARIA is following. And again, that is exactly the reason why I was asking a question after your keynote as to what is the blocker that is stopping soft robotics from being commercialized. So if those are the ones that can be identified, those are the ones where the funding could be channeled into.
Okay, yeah. I mean, I can say what I said beforehand. So, I mean, soft robotics is fairly young and needs more research. So maybe my answer would be yes, fund research into soft robotics, and we will be able to overcome these blockers.
Yeah.
Yes, yeah.
I can't stop myself from saying we need to worry about the software as well, because you can't sell the hardware if it doesn't have reliable API for you to program it. So it's a robotic platform, it's not hardware.
Yeah, they need to work in tandem. I agree with you. But at the moment, the gap is like there is the quality of the hardware is not at the level where it can leverage the advances that are happening in the software and AI.
That's true. So there is a misconception fueled by the media that we are much further ahead than we actually are. Yeah.
You think we're not as far ahead as people
Some
think?
people think that, these hands that we've seen, that's all solved. That it is
yeah. I mean, you
because
look.
They watch the films.
You look at the.
I'm talking about general public.
Yeah, and not necessarily hardware or software, just some solutions which we can see on the screen, on the big screen. Yeah, okay. Magic. Yeah. Okay. Any. There's a hand and there's another one.
Because we have a question left from last one, so.
And we have another hand over there. Okay, good.
Yeah, thank you for this talk. We know that robotics is now advancing extremely fast, from theory, software, and hardware. But I think there is something missing from this fascinating journey is the way robotics is taught in the school and the universities. In your opinion, what are the main challenges that faces universities to teach robotics? There is no clear path or how one can start from zero to the advanced. And are we ready now to add courses in the high school, for example? Thank you.
Maybe I can start. I agree. It's a big challenge because it's very multidisciplinary. Lots of aspects come into robotics. It's engineering, electronics, computing, possibly materials, and more. Not even to speak about ethics or AI and trustworthiness. So it's just too much. It doesn't fit into one bachelor program. So one has to pick elements of it and teach those. I would suggest. I mean, me personally, I think giving the students a good foundation in these areas, and then possibly pick one and specialize in that, and then the graduate needs to maybe continue learning on the job. I think that's the only way forward. But I like your suggestion about schools, high schools, to start already early. Again, what would I suggest? Programming is definitely a good area. So if students learn programming in school, they could then bring that forward and learn the other aspects at university.
I think Kaspar, just to follow up on what Kaspar was saying is, Queen Mary University was involved in an effort led by Ocado. When I was there, I was co-chairing, and Cranfield University was involved as well, where apprenticeship standard was approved by IFIT, One is for undergrad at level 6, where you get a bachelor's degree. And the next one, which I led when I was at Ocado, is a master's level apprenticeship program, which gives you a MSc in robotics towards the end. And Queen Mary is strongly trying to launch that program later, and Cranfield is trying to launch the level 6 apprenticeship. So building the skill level, that has already been identified, and efforts are being made. It's just that the result takes time for it to show up. Sorry, Rob.
Just to first of all, thank you for reminding me of that. Yes, obviously, that's happening at Queen Mary. And it was very good collaboration with Ocado there. What I wanted to add, what I also like about the apprenticeship program is that it's in conjunction with companies. So the companies are the end users effectively, and can and do help shape the program that we are then offering. And so we create the program in a way that the students are educated, or the apprentices are educated in a way that it makes sense for the companies involved. Yeah, so thanks for that. Yeah, sorry, Rob.
I think for STEM, I think there's quite a lot of useful tools out there. I mean, Lego Mindstorm, right, which is a fantastic kit which allows you to, to actually build a robot. You put the sensors on. You've got a simplified programming environment where you put blocks in and things to get you going. Also, Raspberry Pi, you've got robot kits as well. So I think that there's the tools out there. I think the problem is to get it into schools is the school curriculum is quite packed anyway. My wife was a teacher for many years. So it's trying to pack it into the curriculum, and also having teachers which have also got the skills to get the programs going effectively. I think those are maybe the two barriers for me.
Yeah.
Really good point, Rob. I just want to add on to that. I spoke with the Department for Trade recently and asked them if they had a contact in the Department of Education to talk to them about robotics, and they said don't bother, because they're fighting fires at the moment. They can't get enough teachers to teach the existing curriculum, let alone think about improving the curriculum and making it more appropriate for the future. It's maybe an opening for private companies that could start a business that goes into schools and teaches robotics on a kind of irregular basis.
Yeah.
I think it's so important to get children interested in robotics and STEM in general at a very early age. In a lot of places in the country, it's not even an option. Their dad's maybe a shop worker, mum works at the school. They not having the knowledge of what is possible can hold people back, and they might not even think that they can go down that career. So yeah, it's something I'd like to channel some funding into, skills at all levels, going from primary school kids before they get kind of to be cynical teenagers, technical T-levels as well, apprenticeships, and upskilling older people as well. The people that are perhaps being displaced by robotics can be upskilled to then operate, install, service the robots themselves as well.
Yeah, very good. I think there were some hands up. Yeah, okay.
Okay, kind of follows on a little bit. So we've got many robotics experts here, and we're all trying to build robots to do practical things in life, to make life better. And then on the other hand, we've got people who are very good at these practical jobs. So building houses, building brick walls, driving lorries, cleaning hotel rooms. But there seems to be a disparity, because I bet none of us robotics engineers could build a wall. So there seems to be a disparity between the jobs that we're trying to build robots to do and the experts who can actually do those jobs. And I don't have the answer, but what do you think we could do to close that gap so we can build robots that can actually do the jobs that the experts know how to do?
I'm very passionate about this area, so I'll kick it off. So That's exactly I was saying about interacting with the end user right from the beginning. So that's when we actually know what is the job that needs to be done by the robot. And if the person actually requires a robot just to assist them or take over the job so that they can do much more easier job. I have been to some facilities where people are so quick at doing stuff. I've been to one semiconductor electronic PCB board manufacturing, so where there are very tiny resistors and capacitors, and people are so quick at putting them on the PCB boards and sending it off for soldering. I can't imagine a robot doing that at any point in the near future. So chatting with the end users right from the beginning, understanding where the challenge is and where they need support from technology is what I strongly believe. But I know there are other views that panelists can share.
I entirely agree, and I think I'll go back to the point I raised. It's a multidisciplinary problem. We need to recognize it from the start. So we are starting a CDT on lab automation in the University of York. We have a session tomorrow, and it's creating that kind of environment where the co-directors are myself as a technical person and a chemist. He's here. I think he's outside now, unfortunately. But it is that collaboration between the expert and the technical people with sociologists, lawyers, psychologists, and so on, talking from the start. Otherwise, we build the robots and no lab is ever going to want it.
Maybe just to add, I mean, I think the issue is it's just too difficult. I mean, these are experts in their fields. They can do these things very well because they have trained possibly over many years. Robots are not quite there yet to do these jobs. Although it's slowly coming, so we have self-drive cars that might help the lorry driver, and Rob is working on systems for the home to clean the place. Yeah, so.
Do it quick, Rob.
So I suppose we are moving in the direction, but maybe not fast enough for you. Yeah. Good. More questions?
Yeah, I've got one. Just a comment before that about the education thing. If you're interested, you can always sign up to be a STEM ambassador. Any school across the country will more than likely be very happy for you to go in and volunteer and run a session, whether that's in high school or primary school. It's really easy to sign up, and they sort out your DBS and everything for you. So it's all open online. Really recommend. So my question was kind of going back towards what Radhika was saying about kind of trust in the general public. It is a really big problem, people trusting autonomous robotics, and I was wondering what you as a group think maybe we could do as a community to increase that trust going forwards for autonomous robotics.
Yep, I think that's a good question. Maybe just to link it also to what I hear sometimes from people, that they are really afraid that in the long run robots will take over the world. So what is your view on that, and how can we make sure that people are, calm down?
Well, I'll start. Even with a simple robot like a cleaning robot, right? When people first get it, they're running it for short runs in their home because they're building trust in it, right? They don't want it damaging their furniture and things, so they want to be on hand. To help with it, and then they build up their trust, and then they'll run it then, but they're still in the home, right? And then, so they're on hand if they hear something, and then eventually, they can set the robot up so it's doing the cleaning when they're not in the home. So they almost want the robot, in my opinion, to become invisible, right? So they never see the thing running. They just come in and they empty the bin, put it back, and then. But in order to get there, they build up this kind of trust over time, I think. I think that's what happens in my area.
I agree with you there, Rob. Familiarity breeds trust, doesn't it? So the more that we see them around us, the more that we're going to trust them. But I think it's humans ourselves that are going to really decide whether robots are a problem or a great thing for the world. It depends how we use them and how we redistribute the wealth that's generated by them. I read quite a bleak picture of what a future world with robots could be recently. It's a novel called Service Model by Adrian Tchaikovsky. And basically, we've got robots to do everything, and then we just sit in our homes, and outside the world's burning, but nobody notices because we're all so comfortable. That's not a situation that we want to get into.
But is there a danger that we could get to that? I mean, I hear sometimes people say, okay, I'm afraid of robots. These machines one day will be more intelligent than we are and just switch us off, and do what they want.
I don't think that's a danger. It's more us not acknowledging what's going on outside. It already happens with, Netflix and all your comforts in the home. Maybe you don't take so much care of your neighbours because you've got lots of technology to distract you from what's going on in the street.
Okay.
Jonathan, if you remember when we first met in Milton Keynes at the European Robotics League competition, the reason why I'm bringing that up is there is a facility in Milton Keynes where small sidewalk robots are being tested. So they are used for delivery of small goods. So they are being tested in a space where there are people that are walking around and like people coming into the shopping mall, etc. So initially, the reaction of people is, what is this strange thing going around? And they used to avoid and go in a different route. But watching them over and over, they got used to it now. And let us say if a sidewalk robot has tipped over, they are now coming and setting it up right and asking it to go. So it's all about building that trust and making it acceptable. That is where I believe is the strong point of acceptance.
I work with Holly, who asked the question. So I think that her finishing her PhD thesis that will allow people to verify system behavior, take into account assumptions about humans, will help a lot, Holly. So, well done.
There was,
okay.
I think Mark as well. Yeah.
Yeah.
Okay.
This question might seem unrelated, but I think robotics has been always open-minded to AI, at least from much earlier stages than other disciplines. And probably a very unpopular opinion is that AI is being overused in lots of things. So related to the funding problems that roboticists are facing, the trustworthy and so on, what's your opinion on the abuse of AI in robotics?
So by abuse, you mean that it is used too quickly before one maybe explores other methods, exactly. More analytical approach?
Other methods that have been well established before and probably will give same results in less time.
Yeah, I mean, I personally think we should at first try to find analytical solutions, traditional ways to solve it, as deterministic as possible, and then when there are gaps, to see whether AI can help us to really solve the issues we cannot solve otherwise. But that's just my view. So I mean, you've heard of DeepMind, and their approach mainly is to just learn from scratch all the way a controller. And yeah, interesting approach, not necessarily the way I would approach things. But yeah, what is the view of the others?
I think as an industrialist, I think to go from sensing to actuation for a product is still a way off, I think. So I think, again, it's as you were saying, Kaspar, is to, what are the things that we can't do or find really difficult to do now, and can AI solve those parts? I think for me, that's the way to start anyway. What happens later on, you may then end up, in a few generations where actually it's easier to go from sensing straight to actuation. But I think that's a way off.
I hope not, but yeah, okay.
I'm absolutely delighted to hear these opinions of you guys, because of course to verify an AI component, the big difficult problem is where is the specification? And having the analytical solution is the answer to that question, where is the specification? So if you have it and then have, for whatever reason, flexibility, performance, whatever, decide that you need to use an AI, having the analytical solution is the starting point for you to be able to say, in this context, it's all right to let go and use an AI component. But it solves a very critical problem of what is my specification. So I'm really happy with your answers.
Yeah, I think the funding bodies are slightly staying out commenting on this. I'm slightly concerned about commenting on this as well. But there are many academics here as well. How many of you see abuse of AI in producing written pieces from your students? Any raise of hands?
Plenty.
You don't need to answer.
So, I know that there is every chance of it being abused in different areas, and there is that chance as well in robotics too. But where is the need to accelerate the positive use to solve something is what we need to focus on. Other than that, I don't know. There is always this kind of a cold war between robotics and AI that keeps going on. We have to just go with it.
Mark.
Right, okay, cool. Just to add to that debate, it's been, I don't know, maybe 4 years ago at ICRA, so where Manuela Veloso of CMU gave a really passionate speech, and the main line was, we must not stop thinking, in response to this sort of end-to-end machine learning, where basically there was a paper that was learning Dijkstra's algorithm, right? And we know it's optimal, right? There's no point of learning that, and so that at least the plea to everybody is compare your new idea against those that are well established. Not always is end-to-end learning the answer. What I was more interested in mainly, this goes probably mainly to Anna and maybe to Radhika as well to some extent, is do we need a different culture of failure? I mean, we all know from big institutions that they want to establish a culture of failure because we know humans make mistakes, and we really embrace these mistakes to then learn and get better. Now, what strikes me is that with AI and machine learning, we see a very different types of failure, something that we humans don't really appreciate and really can easily understand. There was these examples, I forgot what it was. Was it Tesla? I don't know, where they basically run over a cyclist. Forgot who it was. One of those companies, right? Which was something that no human would do. While still, if you take a completely quantitative approach, you would say autonomous driving will improve safety on our roads, but we will kill people, we will kill them in a way that no human would kill them, right? It's different types of mistakes that are happening. And is that really something where we need to change also the societal point of view? I would argue that we must accept that these things will fail. What you see at the moment, quite often, when AI fails, it's turned off. Right, so with Gemini image, the image generation of Gemini failed to produce, well, it took diversity a little bit too far. The response was, oh, we turn it down, right? It's broken. And people don't accept machine learning, AI, robotics to fail. The moment it fails, it's doomed. And I come back from this, I worked for Mercedes back in the days, and they had an autonomous driving car 20 years ago. And the department that shut it down really was on the one hand marketing, because they said, oh, people like to drive Mercedes and they don't want autonomous driving. But the other side was the insurance side of things, where they said, oh, the moment we kill a human with autonomous driving, our brand is dead, and we basically don't exist anymore. So the question is, if we want to make progress, on the one hand, do we need to accept more failure? And what can we do also to educate people and educate ourselves so that we ensure that we learn from these failures? Is there a principled approach in the context also of trustworthy autonomous systems?
I mean, very good point you're making there, and I think it's the wrong approach, this kind of knee-jerk kind of approach, switch off everything the moment something goes slightly wrong. My kind of logical thinking there would be to say, if overall the new approach, the AI approach, gives better results overall, statistics are improved compared to the human, then I would hope this approach can be further used, because obviously it shows to be better overall, even though strange things happen in between. But how to bring that to the public or to a company who is afraid to lose their name, I don't know.
First of all, I want to thank you for this question. It's so interesting. As you can imagine, I don't have the answer, but I think that it highlights one of the issues, that it is the importance of public engagement, of bringing the conversation to everyone, so that we can educate is patronizing, but that we can listen to each other and understand what's going on and how to react to that. Yes, just saying failed, stop is wrong. On the other hand, I prefer that than the situation we see with software, which I think is very damaging in many ways, where people accept that software fails and they don't mind. In every public engagement activity that I get involved in, I remind people that if you buy a piece of equipment and it's cracked or broke or anything, you want your money back, you want another one. If the software fails, you think about, when is the upgrade is going to come? So there is a kind of acceptance in our society that it's so right to fail, and that people say, it's not safety critical, and then I don't like to talk about disasters, but the people in the UK will know about the Horizon scandal. Nobody would think that a simple database transaction system, simple, it's distributed and so on, would become safety critical, and it became safety critical, have destroyed the lives of people, because there is absolutely no insistence from our society that software that's running our infrastructure at all levels need to have a good level of quality. So actually, I'm not worried that people think something failing, they say stop. Yeah, at least that.
Culture of failure means you appreciate that, right? You don't sweep it under the carpet. It's exactly that.
Exactly.
That's one of the big examples where they have, maybe a lot of people say, that's a bit odd, but yeah, maybe the system isn't quite working. Let's just turn it off and on again. And that's why they didn't embrace the
Absolutely. We need to be more responsible, I think, is the word of the moment.
Hi. I have a robot vacuum cleaner. It's not a Dyson.
What?
Sorry.
Stay back.
It's okay.
So one day when I was at work, it came out to vacuum the house when it wasn't supposed to, because I'm incompetent at programming it. And it set off the alarm on the house. So I then got a phone call from my neighbour to say the alarm was going off, immediately followed by an alert from my vacuum cleaner to tell me it got stuck in a corner somewhere in the middle of a work meeting. So I suppose on a slightly, following on from the failure of robotic system, this was actually not a failure of a robotic system. It worked perfectly. Yeah. But it conflicted with other things that were going on. Yeah. So I suppose on a lighter-hearted note, do you have any good stories of robots failing in slightly comedic ways, or maybe conflicting with other things?
No, I've got a story that I do tell. Is this being filmed, by the way?
Yep. Yes, it is.
We were, when we first released the robots, we do trials, and people sign forms to say that we can get some data back and things. And we are having a report that something had gone wrong with one of the cameras, and it was like, I don't know if you were at the presentation I did, but the first camera we made first 360i was really complicated. It had 2 diffractions, 2 reflections, before the image got, and then lots of small parts that had to be kind of glued together, and it was quite tricky process to get together. And then from the trials, we had reports that one of the cameras was behaving oddly in that 2 parts of the image were not changing, and there were some funny reflections on them. So we were like, oh no, this is a nightmare, because we're making the camera now. The yield is good. Something's gone wrong. So we sent somebody round to the house, the field application engineer, to have a look at the robot and retrieve it. And when he got into the house, it was in Japan, the lady who got the robot had put 2 little ears on the robot to personalize it, and of course that was being picked up by the 360 camera. So that was the problem. So we had to kind of say, look, well, actually, it'll work a little bit better if you take these ears off. So again, you never know what people are going to do with your product. I think is what we learned from that.
So, seeing as though there's 2 people on the committee that are basically money givers, I wanted to kind of see what you guys think about what are the difficulties and what kind of advice you have for someone who's currently working on, let's say, a lower TRL level of work and would like to introduce it into industry, or like pick it up but to a higher level of TRL.
Definitely speak with end users and try and find an industrial partner to collaborate with. Certainly larger companies like Jacobs, for example, are heavily into R&D, so you may be able to get even private funding from them to work with them. Currently, I don't have a pot of money for robotics, sadly, and the way things are going with the new government, it seems to be there's more cuts than increases in innovation spending. So I'm not hugely hopeful for robotics money soon, but we're always trying.
Okay, thanks, Jonathan, and thanks for the question. So from commenting just from the ARIA's perspective, so that is exactly the complementary way of working when compared to other funding avenues that researchers can seek within UK, is be it a small company, medium or large corporation, or if you're a researcher in a university, or if you're a person working on your personal project in a garage, you're still eligible to apply for funding, ARIA's funding. If it is at a very low TRL level, that is where ARIA is trying to take the risk, but risk, not a blind risk, but risk in the sense of whether we see the potential in that technology coming to a level which is suitable to solve or bring a breakthrough that can impact the society. So if you can convince ARIA in saying that this is going to create a breakthrough because this is going to unblock this element of what is stuck at the moment, then you're more than welcome to apply for it. And there is currently an open seed funding call. If you can go onto the website and see specific to robotics. But there are other program areas as well within. One is safeguarded AI, other is nature computes, programmable plants. And there are 7 such program areas, and there are live funding calls. Please check ARIA's website and see if anything is suitable.
Good. Okay. I think we are coming to an end, so I think it was a very good discussion. If maybe anyone, or if everyone in the panel wants to maybe have a final 5-second thought, or you're all happy?
I've got to go and catch a train.
Good. Okay. Then it's good that we come to an end. So thanks again for the panel. I think we had a good discussion. I would say robotics is coming. There are issues. We have to look at trustworthiness quite a bit, transparency. AI is a black box, and we have to see how we best deal with it. I think we are not quite sure yet, what it all holds and how we can best deal with it. But my understanding is also to involve the public as much as possible and give the public a chance to get used to it and learn from it and learn how to live with it. Yeah, good. Okay, thank you very much, and thanks for the audience for listening. Thanks a lot.